When we talk about the universe, in the beginning there was the Newton's concept about the universe, that there is no relation between the space, time, and the planets in the universe. We have actually the planets and the space are not relative to each other. They are separate things. But after the Newton, the Einstein came and he created a new theory. He gave a relativity, general relativity theory. And according to that theory, the space, time, and the mass of the universe, the stars and planets, everything are connected to each other, and they behave relatively with each other. Okay, everything's are relative. Everything's are connected to each other.
Assumptions among the astronomers that the universe is static. So here G mu is equals to R mu V minus 1 half G mu V R equals to 8 pi G T mu V upon C to the 4 minus G mu V omega.
Cosmological constant has two effects: anti-gravity effect and density increase effect. Whereas the anti-gravity effect is derived from the Hubble constant, and the equation is Friedmann equation, which is following like this: the rho, pressure, and the omega. And the density increase effect, K, the curvature, omega, dark energy, and rho, energy density of matter. Is everything are connected to each other, Einstein produced a new model, and according to that model, the space and time is a form of cosmos which are affecting to each other. The sun is affecting to the earth, and earth is affecting to the moon, and the galaxies are relative to each other, and they are. Edwin Hubble created a new announcement during his time, and he announced that actually the universe is expanding, not static. And after that, the scenario changed, and though Einstein had to make some changes in that equation, in his equation he added the cosmological constant to stop the fall of matter into the center, because if that was predicting the static model of the universe. But after the Hubble's announcement, he removed the cosmological constant. That was the mistake by him, and now this is confirmed that there is expansion in the universe, and around 13.6 billion years ago that happened. Really, there are strong evidence about the Big Bang, and all the data of cosmology and astrophysics we have know are aligned with the Big Bang theory, and that was perfect. Three situations of expansion of the universe: either the universe must be the flat, or it must be the expanding forever, or that should stop its expansion. So the curvature that is formed due to the accelerations and the expansion of the universe is affected by the dark energy. And dark energy just confirmed. The three scientists have won the Nobel Prize in 2019. That because of strong evidence in the reference of dark energy and dark matter, which are strongly affecting the acceleration of the universe. The galaxies are moving apart from us, so the data of the dark energy and the dark matter are aligned, and the expansion of the universe is accelerating. Sometimes the data tells that there is a slow expansion in the universe because of the galaxy are shifting away from each other, and the density of the dark energy is changing, and these changes in the dark energy are telling the behavior of expansion rate. Sometimes this is accelerating or just deaccelerating that behaviors. This is my second telecast on the universe and the dark energy contents. In this content, I'm just trying to the reference of particle physics. In the beginning, the particles were formed due to the expansion and the inflation of the universe. How the matter was formed and the particles were formed because of hot and a very dense state of matter, and at the singularity that there was a high density of the matter, and all the forces of strong force, the QCD force, electromagnetic force, weak force and gravitational force were confined into a very high dense singularity at a tiny pinch of matter. But later that the gravitational force, because it turns weak, and that leaves that density state, and all of the remaining three forces are getting loose. They're losing the density and the radiation field of the gluons and photons, and the weak force start to decay, and the explosion happens, and the radiations and the matter that expands, they slowly condense down, they forms the particles, electrons, neutrinos, and the quarks. They get confined because by the time they condense and they start forming the particles. That's the particle physics we talk about, because in the beginning the particle physics is the main thing that can solve the problem of or singularity issues and the inflation model of the universe. That's it. We can see that the formation of the particles and the confinement of the quarks into the QCD model. We have a QCD model, and most of the predictions are true of QCD theory, and the particle physics has been tested. We have LHC, Large Hadron Collider, and we are getting the data every year. We are collecting, we are understanding the universe, we are understanding the matter deep by deep, time by time. We have created the standard model of particle physics. We have a set of particles, we know the symmetry of the particles, and which is just in the support of the Big Bang theory. That's it. We know we are studying the Big Bang theory, and we are getting deep into the state of particles because we are studying the particle physics. We are doing the experiments, and finally, because of this expansion will continue, and where we will go. That's it. This is the scenario, and this is the matter. Would we see the future in the next time coming, or would it be just end with a disaster? The data will tell, because we are collecting the data and we are gathering the information. We are making the series of informations is the beginning and to the end, from the Newton's theory to the Einstein's theory, and the now present cosmological, astrophysical, and the particle physics data are telling the future of the universe and the future of humanity on the earth. Picture of universe which has been taken by the cosmic microwave background radiations analysis, and on a large scale we have seen that the universe and the fluctuations received from the cosmic radiations are just shown by this picture and these graphs. and there are variations and temperature variations everywhere. There are density difference because of galaxy density and the dark energy and dark matter presence, and there are density variations in each spot in this model are telling about that the dark energy is holding everything together, and expansion force because of due to the Big Bang is expanding everything, or it will be condensed down, it will stop down, or what will happen in the universe in the upcoming year of years, the millions of years.